we want to find an equation of a quadratic function that has a complex zero of 2i. Notice how they're only giving us one zero, but since it's a complex zero or imaginary zero, these come in conjugate pairs. And complex conjugates are always in the form of a plus or minus bi. So if 2i is a zero of this quadratic function, then so is negative 2i. So our zeros are positive 2i and negative 2i. And when given the zeros of a quadratic function, it gives us information about the factors of the function. So for review, the zeros or roots of a quadratic function are the x values for which the function f of x is equal to 0, and if our zeros or roots are r sub 1 and r sub 2, then the quadratic function must be equal to any constant a times a factor of x minus r sub 1 times a factor of x minus r sub 2, where r sub 1 and r sub 2 again are the given zeros. And one last comment to make is that graphically, if these zeros are real, which they're not in this case, then the x-intercepts will also be the zeros of the function. But since our zeros are not real, if we graph our function, it should not intersect the x-axis. So going back to our example, given the zeros, our function f of x must contain a factor of x minus the first zero, so x minus 2i, and it must also contain a factor of x minus the second zero of negative 2i. Now we could include a constant factor here, but there's no need to in this example. Let's go ahead and simplify this second factor, and then we can multiply this out. So we'll have f of x equals the quantity x minus 2i times a factor of x plus 2i. And again, it's important to notice that when the 0 was positive 2i, the factor was x minus 2i, and when the 0 was negative 2i, the factor was x plus 2i. Now we'll go ahead and find this product. Remember, there will be four products: 1, 2, 3, and 4. So we'll have f of x equals x squared, and then we'll have plus 2xi minus 2xi, and then minus 4i squared. Now we'll simplify. Notice the two middle terms are opposites. This would simplify to 0. And now we also need to remember that I squared is equal to negative 1. So now we'll substitute negative 1 for the I squared and simplify again. So we'll have minus 4 times negative 1. So one possible function with zeros plus or minus 2i would be f of x equals x squared plus 4. Now again, for this example, graphing it's not going to be a big help, but we should be able to recognize that if the function has complex zeros, or in this case imaginary zeros, it will not intersect the x-axis. So if we look at our graph, notice how it does not intersect the x-axis because our zeros are not real. Okay, I hope you found this helpful. We'll take a look at another example in the next video.